Hey guys, do you want to know what an equilibrium constant is and what exactly the Kc value is? Look no further, you're in the right place. You already know the properties of an equilibrium reaction, right? If not, check out this video for a short recap. In an equilibrium reaction, the reaction rates of the simultaneous forward and reverse reactions are always equal. We've already worked that out schematically. But how can we actually describe such an equilibrium reaction in chemical terms? First of all, let's take a very general formula for an equilibrium reaction. The reactants A and B react to form the products C and D, and, at the same time, C and D react back into A and B. The forward and reverse reactions are shown here by the equilibrium arrow. So far, it's pretty straightforward, isn't it? Then, let's carry on and dig a little deeper. What's most important for the equilibrium reaction are the reaction rates of the forward and reverse reactions. And you can calculate those. The rate of the forward reaction is expressed by the value Vf. And this in turn can be described by the following equation. Vf is Kf times the concentration of the reactants. So the concentration of A times the concentration of B. The constant Kf is a fixed value which describes the rate constant of the forward reaction. The rate of the reverse reaction looks very similar. The rate of this reaction is described by Vr. Here's the equation. Vr is Kr times the concentrations of the products. In the same way, Kr gives you information about the rate constant of the reverse reaction. When the equilibrium reaction has reached the equilibrium condition, Vf is equal to Vr. The so-called equilibrium constant, Kc, can be determined for such an equilibrium reaction in order to find out on which side the equilibrium will eventually be. We already know that the reaction rates of the forward and reverse reactions are always identical in equilibrium, but the concentrations of the products and reactants can be different. And we want to figure out these concentrations with the help of the equilibrium constant Kc. In other words, we use the Kc value to find the point of highest concentration. But that isn't always fixed, because the Kc value is dependent on temperature. So it can be influenced by changes in temperature. But how exactly do we know when a given Kc value describes a higher concentration of reactants or products? Well, good question. There's a really simple explanation for that. And it's best just to learn this by heart. Remember, if the Kc value is greater than 1, the equilibrium lies on the product side. So we have a much higher concentration of the products. Otherwise, if Kc is smaller than 1, we can conclude that the equilibrium lies on the side of the reactants. Then we have a higher concentration of the reactants. Does everything make sense up to here? Great, because that's all we want to cover today. To summarize, the general formula to describe an equilibrium reaction is particularly important here. Once you have that down, you can either derive the other stuff or just memorize it. We know that in the equilibrium state, Vf and Vr are the same, and how we can use that to obtain the equilibrium constant. That in turn tells us which side of the equilibrium reaction has the higher concentration. That is, whether we have more products or reactants. You can see step by step how exactly the equilibrium constant is calculated and what the law of mass action has to do with all this in the next video. That's really important. Be sure to check it out. See you guys soon in our next video.